we 외국에서 오신 학생인데요. 우리 아주대의 퍼스피타 라티흐 키크마흐 라는 연구원의 발표를 듣겠습니다. 발표 제목은 Leveraging the Clustering Algorithm for Distributed Spectrum Sensing in Cognitive Radio-Based Reinforcement Learning입니다.
Hello everyone, good afternoon. My name is Rati Hikmah Puspita. I'm from Aju University, and today I'd like to present my paper about the leveraging the clustering algorithm for distributed spectrum sensing in cognitive radio-based reinforcement learning. And here the content of my presentation today, and I will begin with introductions. In cognitive radio for design, the wireless communication system has been proposed to mitigate the scarcity problems of limited radio spectrum by improving the utilization of the spectrums. In the CR network, there are two variables: the primary user as a authorized user who can use an allocated frequency band legally, and it should be interference-free by other users. And for the secondary user, perform dynamic spectrum sensing on their surrounding spectrum usage and try to find the either spectrum, and it's called a spectrum holes. And here for the machine learning base, we use in this work we play the future of the current bands, current frequency bands, and transmit power and SNIR, and we implement the reinforcement learning in this in the sensing. Its CR is distributed to get relevant spectrum information, and process of the information they share the sensing description with the other CR. And in this work we define the region potential interference here, and however by defining the RPA area, some of secondary users who outside the RPA area cannot detect the presence of primary users. Therefore, we leveraging clustering approach to increase leveraging the clustering approach to increase the availability of primary user detections by defining a group of CR performing a distribution of spectrum sensing as a cluster of sensings. By using a list, the sensing cluster make a decision as to whether primary user present or not. And for the reinforcement learning, currently the reinforcement learning is useful for machine learning algorithm, which an agent learns the method to behave in an environment to maximize the cumulative rewards. And as the case of cognitive radio networks, the dynamics of the system are highly unknown, and the system environment is highly ascertained, as the primary user may join or depart the frequency spectrum at any time. And the purpose of this work is to analyze the cognitive radio clustering in the context of distributed spectrum sensing, as well as to analyze the performance of metrics for evaluating clustering method to be distributed on spectrum sensing. And it's also to solve the issue where the secondary user is outside the region of potential interference or RPI and is unable to detect the presence of primary users. And here the related works for this works. The next content is about the system model and approach. For the system model here, we consider one primary user and secondary user in single channels. for the first secondary user is represented by SUI, where I is 1 to n. There also consider K clusters and with the K cluster hits, and it's denoted as CH. In the schemes, it is assumed that spectrum sensing is carried in urban area, and primary user transmit the power in all directions or omnidirectionals. Then, before the distributed spectrum sensing process, they will use the clustering. They will use the clustering approach to make it one cluster from several secondary users. And after the user generated randomly by x and y coordinates, the distance will be calculated from each secondary user to primary user and secondary user to other secondary users. And for this system model, secondary users are randomly distributed around area 2,500 meters by 2,500 meters, with diameter of RPI area is 1,000 meters. From the random secondary user position, there are two conditions. The first condition, sensing from the transmitter properly, because secondary user is in the RPI area, so it can detect the primary users. But the second condition is while secondary user that outside the RPI area and cannot unable to detect the primary users. Then we use the clustering approach to solve these issues. And in this simulation, we deploy nodes in a network into clusters, and we randomly selected the cluster hits. In other words, cluster hit will be randomly selected among 8 nodes that we already defined, and the next cluster hits determined by calculating the Euclidean distance from CH1 to all other nodes. Among them, select the maximum value and choose as a cluster hits, the second cluster hits. And for the next clusters, we take the next maximum value and calculate the distance from the cluster hits one to another nodes. It will be repeated and processed for the selection of K cluster hits. And for the learning method, we use the Q-learnings, where the measurement taken by each secondary user during the first visit to the individual learning process. It performs the initial step at the beginning, where the Ki is equal with 0 for all secondary users. Then secondary user already exists within the network have already learned their own Q table, and the newcomer of the secondary user will initialize its Q table and collect the present users of the average the Q tables. And for the simulation results, here the detection probability. According to the first figure, it's shown that detection probability value of SU2 and 2SU6, they perform a good probability of detections. While for the SU1s, the probability of detection was very low and below the threshold. Is it because as secondary user 1 not in the RPI area, it outside the RPI area and cannot detect the presence of the primary user. So after we implement the clustering approach, the performance of SU1 increase to detect the primary user's presence. And for the next parameter is the false alarm probability. It's same the conclusion as the detection probability, while others secondary user except SU1 achieve the low false alarm probability because SU1 still outside the RPI area. While after we implement the clustering method, the performance of false alarm probability slightly increase and it's improve the performance. And here the conclusion of our works. The first, the clustering approach used to solve problem where the secondary user is outside the RPI area and it's unable to detect the primary users. It caused the high probability of false alarm. And the clustering approach may provide the information on the presence of primary users and increase the detection probability value. In the simulation result, so using the clustering approach, the entire secondary user can detect the presence of primary user with detection probability value around 0.85. And clustering can also improve false alarm probability value performance when EBA null is greater than minus 18 dB. Thank you very much.
Thank you for good presentation. 네. 지금 우리 퍼스피타 라티흐 히크마흐 연구원의 발표가 있었는데요. 이게 지금 이제 발표 내용을 간단하게 이제 우리 말씀을 드리면 그 인지적 라디오 신호 기반의 어떤 강화 학습을 이용해서 그 분산된 센서 네트워크에서 이거를 이제 알고리즘을 집합하는 방식으로 이제 효율성을 증가시키는 연구 주제거든요. 그 질문 사항이 있으시면 질문을 해주실래요?
Conclusion in experiment, I think there only SU1 result by the clustering and not clustering method. I think why this result is generated by the simulation.
Why the excuse me.
In conclusion, there I saw that there is the compare between the clustering method and not clustering method. But I think the simulation results are similar, but only SU1's results are better than not clustering method.
Because when we deploy the secondary user randomly, there are some secondary users which outside the RPI area. Before we define the RPI area, and in all the secondary users which inside the RPI area, they can detect the presence of primary user. But for the secondary user which outside the API area, they cannot detect the primary user. That's why we use the cluster user to share the informations for the outside API area. We want to compare the availability detection of primary user for the secondary user which outside the API area.
답변이 되셨나요? 네네. 지금 네. 네, 온라인으로 질문이 하나 들어왔는데요. How did you set reward function in RL?
Reward function.
Again. How did you set reward function in RL? Reinforcement learning, RL.
Yes.
Yeah, okay.
The reward function is because first we define ones of user, secondary users, and they learn and input the Q tables, and for the next secondary user, they actually for each comer before we calculate the distance for the newcomer user, the distance that's whether they will close or not from the present secondary users, assist secondary users. That's from by distance.
Okay.
We calculate by distance.
지금 혹시 저기 답변을 듣고 이해를 하셨는지 모르겠는데요. 이게 이제 그 첫 번째 그 액세스 포인트, 쉽게 말하면 첫 번째 액세스 포인트하고 두 번째 액세스 포인트가 이제 이동을 했을 때 그 거리 사이를 지금 이제 어떤 강화학습을 통해서 이제 한다는 내용인 것 같은데 지금 답변을 제대로 들으셨나요? 어떻게 됐나? 질문하신 분? 지금 일단 시간이 없으니까요. 지금 일단은 네, 수고하셨고요. Thank you for your good presentation. 네. 다음으로